So, this is the Senior Faculty Workshop on Active Learning. A little bit about where I come from, as in which department I'm from. Professor Patwardhan did mention. This is called Educational Technology. It's a department. It's called an interdisciplinary program. It's a very young department in IIT Bombay. We started in 2010. We have core faculty and associated faculty from various departments like electrical engineering, computer science, physics, mathematics, biology, School of Management, School of Design, Humanities and Social Sciences. So it's a very interdisciplinary program. We have 25 research scholars, current research scholars, and about 10 who graduated in the last few years. Many of them being college teachers, very much like you, both new college teachers as well as senior college teachers. And research and development, we have a strong program on thinking skills and how teachers can effectively use educational technologies. And we've done a lot of outreach on integration of ICT. We've done workshops, we've done MOOCs, face-to-face sessions, small, large, blended sessions, and so on. Okay, so this is a little bit about my background. But what I'm really more interested in at this point is to hear about your background, because that will help us customize at least the sessions of today and tomorrow that ET is going to conduct. Also, this kind of getting feedback from audience is something that you can also do with your students. So one thing you will see us doing, me and my colleague tomorrow from this department, is alternately you will be in the role of a teacher and a student. Okay, so a technique that we incorporate here, you can use with your students when you go back. So I would like to get an idea of this, mainly to tailor the activities in the next few hours. So can I just see a show of hands? How many of you are mainly identify with computer science domains? And okay, when you raise your hand, also take a look around, because there are some activities where you'll have to talk to each other and do something. Okay, so if you're not from the same college, so CS folks, can I just see your hands again and take a look where the other CS folks are? You may have to, at some point, you may have to turn around. When we do examples in a teaching workshop like this, we have to give examples in some domain. And I'm going to try to stick to school level domains which most people with a science or engineering background can understand. Without giving examples, it becomes very theoretical and abstract, and it's just like the teacher on the stage doing some blah blah. That's not the point of these workshops. So I will try to explain the examples, and the examples have been chosen so that hopefully most of you understand it. The point is not to quiz you about your domain understanding, but just for a context. Before we go ahead, this is a senior faculty workshop on active learning, and the word workshop has been underlined. So the workshop starts with the word work, right? So in a workshop, people have to do the work. Who has to do the work? Me, of course. But workshop is all of us together. So I'll be doing some of the work and you'll be pulling a lot of the load also. The second thing, the reason I'm saying this, I'll come to you here in a moment. The second thing is it's a workshop on active learning. This is what you will learn to go and do, take back and do in your own classes. So unless the workshop uses active learning techniques, unless I do this workshop using active learning techniques, it's useless. One can't give a lecture on active learning. Okay, so what we'll do in the workshop is use active learning workshops throughout, which means the moment you see a blue slide or some different color slide, it means you have to do the work. Okay, so we'll start off with a work. What I'd like all of you to have is some pen and paper or any writing implement, okay? Or if you want to take, write on your tablet or so, I don't mind even that. Okay, so you're all teachers and instructors and faculty members with varying degrees of experience. And I'm sure all of you have thought a lot about what are your goals as a teacher. Essentially, what is it that you want your students to be able to do? So what you need to do now is take a minute, write down, just for yourself. We'll use the clock back there. What are your goals? Write the topmost goal you feel which is important for you as a teacher, for your students as learners or so. Just take a moment and jot it down. So this is an individual activity. Individual activities are individual. You have to write one or discuss with the instructor. In a few minutes, there'll be a pair activity. where you can talk to each other, but this is not the pair activity. Let's start. I heard somebody said impart knowledge. I'm going to say start from there. Impart knowledge. When you say excellence in teaching, madam, thank you. Excellent teaching, and this includes both sound knowledge on the part of the teacher and effective communication. Okay, so absolutely get students to become comfortable with teachers. Better interaction, absolutely. So understand. So let's say I'll put understand along with impart knowledge. Understand, and the goal is that they should understand everything or as much as possible. Agreed. Okay, so knowledge is both about core and basics as well as advanced and research. Career building will do that. See, most of you are, I'll come to you in a minute. Most of you come from a science or engineering background, and even those of you who come from a humanities or social science background, as experts in your field, it's not just knowledge. See, if you look at the previous statement here, okay, it doesn't say it there. You want your students not, when you say impart knowledge and understand, yes, you want them to have conceptual understanding, you want them to know things, but is that sufficient? Apply, you want students to apply. Let's take a few ideas from apply. There was somebody here. Okay, so curiosity, that's a completely in a new idea. So I'll start with apply, and then we'll also write curiosity. Let's explore both of these. When you say apply, can somebody say what is it you want them to do when applying? To make things, to solve problems, make things simpler. Those of you who are from, I think I heard this word, those of you who are from engineering, design and analysis is a very big thing. Social responsibility. Let's come to some of them. So curiosity, social responsibility. These were some of the things you said, and usually whenever you get any group of teachers together, it's something along these lines we get. Because as teachers, we want our students to know and understand, and we want them to do things, problem solving, and we want them to develop correct attitudes. So what we see in the next sentence, next slide, is categorization of our goals. So let's all come back now. So we want our students not just to learn, we also want them to do things. That's what the title of the slide says. Content, of course. Okay, content is knowledge, understand, concepts, all of it. Deep conceptual understanding. How does all the concepts come together? And then you have thinking skills and abilities like problem solving, application, design, experimentation. Did anybody think of experimentation? Hypothesis testing, error analysis. This is very common. And then I didn't write anything here in attitudes because it's very hard to write, and some of you in fact came up with really good ones like curiosity and motivation and social responsibility. So we want our students to be able to do all of this. Right? If you look at this slide, it's very ambitious. We have a huge list of lofty, ambitious goals. That's why we are teachers. That's why we didn't go to industry. That's why we picked a profession like teaching, which many consider to be a noble profession. I won't comment on that, but essentially, this is a common set of goals we have. And essentially, that's why, all of us come together in workshops like this or talk to each other, because this is what we want to do better. So what is the aim of this series of 5 days is essentially what you said in the last 5 minutes. The tricky part is how do we help our students learn and do all? We've written our goals, now it's how to do that. That's what this workshop is about. Right? So before we get our students, before we say here is how we'll help our students do all this, what we'll do for a few minutes is reflect a little bit about ourselves. So think of one activity that you excel at doing. Okay, you don't have to tell this to anybody. It could be related to your profession. It could be a hobby. It could be sports. It could be writing. It could be music. It could be cooking. It could be, you're great at putting together and taking apart machines. It can be anything. Think of one activity that you're really, really good at doing. Write it individually. And this is something I think you don't have to think very hard. All of us know what we're really good at. The next part, you may have to think a little bit more. Think why you're so good at this activity, and again, write down the top 3 reasons. Now I'm going to do some magic, okay? I know I'm not a professional magician, I'm a professional teacher, but what I'm going to do is I'm going to guess at least one of your reasons. Ready? So at least one, for many of you, one of the top 3 reasons is practice or experience. Not too many. Practice or experience, doing it again. This is an activity that you're really good at. It's like if you're really good at playing football, maybe you were practicing football or playing football since your college days. If you're really good at singing, you must have participated, you may have taken lessons from a teacher, you may have participated in competitions and sung and sung and sung. If you're good at putting together machines, or maybe you're good at programming, you must have written thousands of lines of code. So the idea is, I'm not saying this is the only one. You need knowledge, you need a teacher, you need a lot of things. But one of the reasons to get better at doing something is practice and experience. If this was not one of your top 3 reasons, reflect upon this a little bit. Okay, and see if it is true for you. Ask yourself, how much did I practice to get so good at it? And practice need not be boring. It just means lots of opportunities where you do that thing. Every day you go out to play football, that is practice. Okay. Interest is important. Absolutely, interest is important. Good instruction is also important. A good teacher is important. If we're talking of some of the others, let's hear some of the other things which help you become good. Some motivation, zeal to do it. Passion, interest. Let's start with passion and interest. You have to start with passion and interest. Is that sufficient? Okay. Passion is a necessary but not sufficient condition. Passion can help you do the practice and go for instruction. Anything else? Feedback, excellent. So let's take any sports or music. How many of you agree that you can become very good at something by sitting in a room and thinking about it on your own, or by listening? You need other people. You need feedback, you need interaction. So now let's look at practice, experience, feedback, all of this. And let's now think of students, our students. So now you're back as teachers. Suppose somebody came and gave you a set of lectures on how to play football well or how to sing well. Would you become a master at it? See, this is something you're really good at. I think most of us would agree that we can't gain mastery. Maybe some knowledge, but not mastery. So the point to keep in mind here is that as learners, we develop mastery through practice, through experience, not only by listening to lectures. You have to have interest and passion to begin with. No doubt, I definitely agree with that. So now when we shift to our students, this is what we need to provide our students. As teachers, we have to ensure that we provide our students sufficient opportunities to practice, timely opportunities. Allow them to interact with their peers, give them feedback. So this is sort of a top level point that we can, top level insight that we can get just by reflecting on how we become masters at something. Why some of us feel uncomfortable with this is that the circumstances that we are in. I'm in this room. All of you are sitting in fixed seats. Most of the time I seem to be lecturing. So the circumstances are not favorable towards learners, in this case you, doing practice. Because a setting like this is actually more favorable towards lectures. Unfortunately, we are stuck with that. Unless you go to classrooms like studio classrooms, or sometimes in management schools, they have better classrooms, which are not fixed seats like this. In labs, you have better classrooms. Yeah. But even in this setting, what we want to try to do is to give learners as much time for doing practice and as much opportunity for experience as possible. That's the main takeaway here. So the title of this session was called Triangle of Effective Learning. This kind of practice, experience, feedback and all, together it goes by the name of active learning strategies. Today we'll look at a few strategies, we'll talk about it at this level, and tomorrow you'll look at more details of it. One of the vertices of this triangle of effective learning is active learning strategies, which is essentially the kind of experience and practice you do for yourselves when you're learning music and sports and cooking and programming and machining and so on. I haven't defined what is active learning, but this is a feel for what is meant by active learning. Who does most of the work in active learning strategies? In the classroom. So what's the role of the teacher? Facilitator, okay, like, I might say, please say something, talk to each other, that is one role. Here is a hint. The teacher has to do a lot of work also, but before coming to the classroom. What kind of work does the teacher do before coming to the classroom? Design these activities, think of what she wants the students to do, decide how she wants to give feedback to the students. So a lot of thought and work is there behind the scenes. It's not that the teacher is doing no work, but the teacher is not only talking in the classroom. That's the main point here. Okay, so let us look at the other two vertices. We said it's a triangle, so it has three vertices. Let's look at the others. So I actually want all of you to imagine a specific teaching learning scenario. I've taken the example of 11th standard current, voltage and circuits because I thought many of you will be familiar. I'm not going to ask you about anything, but are you familiar with current, voltage, bulbs, batteries, brightness? Yes? Many of you. If you don't know the details, if you don't know, I'm not going to ask you to solve a maths or a physics problem. But this is just the context. Okay? If you don't like this topic, you can imagine some other topic also. So imagine this scenario. Now, what the teacher did is gave definitions of current and voltage. The teacher explained series and parallel circuits. This is something very common, and you can remove current and voltage and put thermodynamics or put adverbs or any topic you want. There are principles and laws in most science and engineering topics. So the teacher explained Ohm's law, which is one of the main principles, and the teacher gave examples, solved example problems, did problems on the board. So this is a very standard, this is what a lot of teachers would do. This is how we learnt as students. What did the students do? These are good teachers and good students, okay? Let's keep that assumption. The students studied the definitions. They studied series versus parallel circuits. They memorized Ohm's law. It's the main law. It's the main principle. And they practiced similar problems. They didn't even stop at memorization. They practiced similar problems. So far so good. What happened on the exam? So now things start getting interesting. So I'll explain this a little bit. So there was an exam problem, and what you will note is that this exam problem has no equations, no mathematics, no formula. It's a physics class, but there's no mathematics here in this question. There were two circuits, and this was completely pictorial. And these yellow things are bulbs. And this is a battery here. Okay? So the exam question said that these are two circuits, the top and the bottom. Determine in which circuit will the bulbs glow brighter. They are identical bulbs. If you know, whatever, it's some answer. Now, can you guess what happened? What did the students do when they saw, or if you don't know this topic, actually if you don't know this topic, this is also a good way of thinking about it. What do you think the students did when they saw this problem? They would try to apply. Did they say it was easy or hard? Many people are saying it's hard, but look, this has no equations, this has no mathematical derivations, no long problem solving. It's just two pictures. Okay, so that's exactly what happened on the problem, what you predicted. Most students were not able to solve the problem, or they were scratching their heads. So as a result, the students were unhappy and they got poor marks, and as a result, the teachers were unhappy, and so on and so forth. So this is the story that is there. So what I'd like you to do, this is all the four of it together. Let's push this a little further and see what happened, okay? The students said this question was out of the syllabus because you all remember this, right? Because we have not done such problems in class. The teacher said the question is really simple. Students, it's based purely on Ohm's law. It's based on series and parallel circuits. We've done so much of it. All they have to do is qualitatively reason. In fact, it's much simpler than numerical problems. So now there is an activity for you. What went wrong? We'll do this in a think, pair, share fashion. So in the think part, what I'd like all of you to do is, who do you think was right? Just justify, write it down. In a minute, I'll allow you to talk. Was the student right, teacher right? Who do you think was right? Write it down and justify. Just make a guess. Not even a guess, just write your opinion here. Blue slide means you have to do the work. Since you all want to talk to each other, let's also put up the pair phase. So discuss with your neighbor, come up with a possible reason for what went wrong and write it. Okay, now you're free to discuss with your neighbor. What do you think went wrong? Something went wrong, we all know that. What went wrong? Write it in your notebook. So you think the teacher was right. Okay, does somebody disagree with the... So you're saying the student is right. So let's try to do one thing. I'm sure when people try to, you try to take a side, you'll be able to give arguments for both. But let's try to understand it from a system perspective. Okay, system perspective means something failed in the whole classroom. So can you reconcile? So you're trying to reconcile. Both seem to be correct because when you say it, I'm going to nod. When you say it, I'm going to nod. Things don't seem to be explained in the right way. So let's try to take this. Suppose both are correct. Communication is a problem. There is no mechanism of feedback. Practical knowledge was there on the exam but not done in class. Okay, so I think innovative thinking was asked in the exam but not done in the class. Okay, so you're saying that there are two things, and so let's see how to try to resolve this. So the main thing is that, look, both the students and the teacher, we are not trying to point fingers here. We are trying to resolve the situation. We are trying to reconcile how to make things better. And it seems like both are right in their own sense, but there's a mismatch, there's a misalignment. That's what, when you said that application was there in the exam but not in the class, or innovative, they were asked to do innovative thinking in the exam but not in the class. The idea is that teacher or the examiner had some expectations that solving Ohm's law problems or applying Ohm's law meant this, this and this. The students had different expectations because of what happened in class. The expectations of the students and the teachers did not match here. Communication, what you mentioned about communication is exactly, it lies at the heart of this. So that sort of brings us to this point that we need to match both of these. Okay? At least if we try to match the expectations with better communication, better setting of expectations, things might become better. So as a teacher, we need to match our expectation with students' level of learning, with how much students, not just how much, with what kind of studying students do. Teachers, we ask this question, what are my goals as a teacher? We also have to ask this question, what is it I want students to do after today's class? There's a difference between my goals as a teacher and what is it that I want students to take away and do. What's the difference? Or think about who's the hero, who's the center of attention here. This one, left one. What are my goals as a teacher? I'm thinking of students, but I'm thinking of what are my goals as a teacher. I want, excellent teaching, clear explanation. Here, we are specifically asking, what is it I want students to do? They're very similar. I'm not saying they're widely different, but it's a shift of the mental frame. So we come to this point called learning objectives or learning outcomes. I'm sure all of you have heard about it, especially the senior faculty, but this problem that we saw, the scenario that we saw, one way to solve it is by what we call as learning objective or learning outcome. Both these words are used. These days, outcome-based education is used a lot more. So here are some examples. Suppose the teacher had written objectives which said that at the end of today's class, students should be able to define or state Ohm's law. Okay? Students should be able to apply Ohm's law to calculate current given voltage. Students should be able to analyze current and relate it to brightness. So if the teacher had written these expectations, these objectives explicitly and communicated it to the students, then hopefully that scenario would not have been so bad. Right? So the idea here is that learning objectives and outcomes indicate specific, measurable performance outcomes of the learner. We'll spend a little bit of time on it in the next few minutes to try to see what is and what isn't a learning outcome. But this is a reason why we need learning outcomes and learning objectives. So definition of a learning objective, we just saw, it indicates specific, measurable performance outcome of a learner. Operationally, so that's a technical definition, but the operational definition is what should students be able to do, and I'm stressing the word do a lot. Do is something so if students do something, how does the teacher know that they're doing it? Students have to do. What does the word do, what kind of impression does it convey? Right, interact, practical, move hands, speak. Do is not think, because we cannot get into our learners' heads. Do is actually any outward behavior, a performance activity. The requirement also must be that this learning objective and outcome must be measurable. It's not just that they have to be able to do it. We have to be convinced that they are doing it. And the way we get convinced is by assessment. So the major takeaway, sort of a big profound point here from that common simple scenario, is that assessment and teachers' goals or learning objectives must be tightly linked. I want to actually show this. So those are the other two vertices of the triangle of effective learning. You have learning objectives, that the student should be able to do something. And you have assessment here, which need to be linked. That's why it's on a triangle here. And then the third one we saw was active learning. All three must have been red here. This slide I'll replace. So these are the three aspects that need to come together. If as teachers we make sure that the three are aligned, we will not face scenarios like that. And effective learning will happen, engagement will happen. There's many studies there. How to do this is again not very straightforward. That's why we have many sessions on this one. But this is setting our goals. This is what we want to aim for. Your goals and objectives should reflect what you value. If you value problem solving and if you value application, the objective should have it. If you value definitions and memorization, it should have it. If you value students doing design, your objective should have it. If you want students to be able to communicate, it should have it. If you want students to develop curiosity, it's a very hard one, your objective should have it. You cannot have objectives where you only write about concepts and expect students to do problem solving. So that's the mismatch. Second thing is you have to tell students what those are, because students often don't know what these objectives are. Okay, so this is a 2-point thing. So basically we are at the stage here where we have to now be able to do all these three. So here is another blue slide, okay. This is a multiple choice question on the next slide. And this is an individual activity right now. So if it's a pair activity, it will explicitly say it. In the individual activity, please read the question, and when I say vote, I would like all of you to vote, not speak anything, but hold out your choice. 1, 2, 3, 4, 5. I can see all of you from here. So I don't even hold it here. We'll come to that, but just hold it here. Which of the following is a learning objective? There are actually 3 things. And then 4th is all of them and 5 is none of them. Take your time, take a minute and a half or so. Think about it, and then I'll say vote after 1 minute. If you don't know the domain, you can replace Ohm's law and current by something that is familiar to you. I'd like you to do. Discuss with your neighbor. Neighbor is spelled wrongly because I just wrote it now. Focus on these verbs. Understand, visualize, know. And I'm going to give you one more hint. What does a learning objective operationally have to indicate? Think about what the learning objective really needs to do with respect to the student. Okay, discuss with your neighbor and just see if which of these is okay, which of these is not. 30 seconds, you can feel free to talk now. If you disagree with your neighbor, try to fight and convince them. But let's observe these verbs. Understand. Actually, this is what I want to put up first. Remember, learning objective indicates specific, measurable performance outcome of the learner. Okay. The words you have to pay attention to are specific, measurable, and performance outcome. Starting from performance outcome. So, actually, it doesn't matter which we start from. Understand. So, if you say that students will be able to understand Ohm's law, or understand thermodynamics, or understand pronouns, understand your favorite topic, can you say a few things what you mean by understand? Everything, okay. Something more specific. What else is understand? Able to answer questions related to what? I mean, what kind of questions? Okay, understand might mean related to concept, but it might mean defining the concept. Applying. So, defining the concept on one hand, applying the concept on the other hand, and everything. So, this understand business is really everything. It's not specific. If you say students will be able to understand Ohm's law, my favorite way of thinking about understand may be that students should be able to write state Ohm's law. Your favorite way may be that they should be able to solve those bulb problems. Somebody else's favorite way may be that they solve numerical problems. And somebody from here might say, understand Ohm's law really means, design. Okay, there's no fan here, but designing the motor of a fan is also Ohm's law. So understand is not specific enough. That's a big problem. Avoid the verb understand in learning objectives. Let's look at the next one. Let's look at number 3. Students will know how a circuit works. And it's not a learning objective because what is it violating? Here. No is also not specific enough. That's one problem. Focus on the phrase performance outcome of learner. So if a student knows Ohm's law, how will I as a teacher know that the student knows? It's not a performance outcome, it's something in their head. So again, if you put the word know in your learning objective, you'll get into trouble of this sort. You have to ask questions. But in the question, you'll ask the student to do something. So let's see what we'll ask the student to do. Let's just solve a problem, apply, draw a circuit is okay. This word visualize current flow, is that acceptable? Students will be able to visualize current flow. Okay, let's try to change this learning objective into a slightly more measurable one. The problem with students will be able to visualize current flow as an objective is, as a teacher, I don't know what the student is visualizing. What kind of a question should I ask so that I can figure out what the student is visualizing? Make arrows, ask them to draw something. Okay. That's one of the easiest things to do. You can ask them to write something also. So the point is, all these 3 are not suitable verbs for learning objectives. One of it is too broad, most of it is too broad, not specific enough, they're not measurable enough. So what we need to do is, none of these options are precisely valid. We need to do better. If we write learning objectives of this sort, we'll get into trouble like that scenario. What we need to do instead is something we did a minute ago. No, 10 minutes ago. State Ohm's law, apply Ohm's law, analyze current related to brightness, draw current flow. Use verbs where what the student does becomes clear. So, 1 minute, समझना लेंगे. समझना is equivalent to understand. पर understand में जो ambiguity है, समझ में भी है. समझ means they should be able to tell what is Ohm's law. They should be able to solve a problem. They should be able to design a motor. तो समझ में ये सारा आ गया. That is one of the definitions, but solving problems is also समझना. तो पहचाना भेद करना it's better for the students if they know कि पहचानना भी है, problems भी solve करने हैं, etc. Right, right. So actually the point is well taken, that samajhna or understand is everything. I mean, when I first asked what is understand, somebody said everything. You're absolutely right. But your students do not know what is understand. Students, it will be much easier for students if they know that they have to define, they have to write, they have to analyze, they have to solve problem. So the takeaway is just this, that take a learning objective which uses understand and write it into a few of them. So in fact, just tell me quickly, what is the difference between a syllabus here and objectives here? This is, now we wrote the objectives. We've been talking about these. What is similar? Okay, let's see what is similar between these two. Columns 2 and 3. There's something very similar in the two columns. Same topic. This is about current voltage Ohm's law. That's also about current voltage Ohm's law. Objectives are measurable, they're more precise, specific, and so on. So basically your takeaways is this. Try not to avoid, understand, visualize, no. Try to avoid it. Instead, use these verbs. That's all the takeaways. Why? Because they need to be specific and measurable. So it's not like what you're saying is wrong. It's not that understand is wrong. But the meaning of understand becomes clearer if you use any of these verbs. Okay, that's the main takeaway when you write objectives. Okay, next point. Are these valid objectives? Suppose somebody says, what are the objectives for your class tomorrow? You say, I'll teach circuit with animation, with examples. I'll show animation to explain function of a circuit. It's there in the don't column, so you know there's a hint. But can you see what's wrong with that, with this? It's the methodology, okay. What else is problematic? Remember, learning objective definition says it is the specific measurable performance outcome of the learner. Okay? Who's the hero of these statements? Or who are these statements for? For the teacher, not for the learner. So learning objectives have to be written from the learner's perspective. It should be concerned with the learner and not what the teacher does. And there's a simple rule here. You start your objective by saying the student will be able to. The moment you say the student will be able to, it becomes concerned with the learner. That's rule number 1. Rule number 2 is in this row above. The student will be able to list or solve or compare. So your learning objectives have to follow these 2 rules.
My first objective I have mentioned, the student will be able to explain the difference between flywheel and a governor.
Okay, excellent. Let's just pause there. The student will be able to explain the difference between a flywheel and a governor. Okay? So this is something again fairly specific. Some people actually go even further. This will work because students also know exactly what they will have to study. Some people actually even put a number there, that students will be able to explain at least 3 differences between these 2. Sometimes that is also done. Okay? Okay, let's take this one. See, even if you don't understand the example, I'm going to comment on how you can apply it to yourself. Please have a seat, okay? All of you don't have to stand. So the student should be able to calculate. Any engineering and science topic requires calculations. So this is a very common learning objective. Anytime you want them to do numerical problem solving or calculation of some formulae and all, you can start with this. So that's very much in line with the learning objectives. And there was one more interesting thing you said. I don't know your domain, okay? So I'm going to skip that part. You said they should be able to calculate the bolts, no? Number of bolts given something. So if in your objective you also specify the conditions under which students are able to do the calculation, that's even more helpful for students. Because it gives the context that given something, they should be able to calculate something. Not just out of the blue. So we are now making our objectives more and more refined. Yeah, so I think what you want to try to do is try to find a verb from here. Try to avoid understand and say if they want to differentiate the sounds or use something like that. So they should be able to eliminate unnecessary sounds. You have to pick a verb. So as teachers, your skill is actually to decide which is the correct verb. Students will be able to state first law. Okay, standard one. Anytime you have a law or principle, students will be able, law, principle, theorem, students will be able to state. Okay, so let's actually look at this explain also. So her objective was students should be able to explain the process of communication, identify the elements, and list some steps of the process, right? Okay, see, the thing is, identifying elements is again very precise. Identifying anything is easy and precise. That will work most of the time. Listing is always very simple and precise, and it's doable. Explain, you have to be a little careful, because suppose I say students will be able to explain the process of communication. Do you want them to say one sentence? Do you want them to write a paragraph? Do you want them to write an essay? Do you want them to draw a diagram to explain this process? So it's a little, it's not very precise. So what you and your students need to be matched on is the format of this explanation. Okay, so the word explain again sometimes might get you into a little bit of ambiguity, and think of making it more precise then. Okay, so I think most of you have gotten a hang of writing objectives. So now we'll go to this other part of the triangle and start writing questions. Where did that go? Let's start writing questions, and then whoever had raised their hand now can explain. Preferable size. Okay, good point. So how many objectives should be there? That's one question. And secondly, at what granularity should be there? Right now I just said write an objective for tomorrow's class. So let me just take one step back and give you a slightly bigger answer. The way you think of objectives is you start thinking of your course. So people write course level outcomes. Okay. And course level are very integrated, synthesized. In course level learning outcomes, usually you don't put state Ohm's law or define something. Those are more for a topic. So if you look at your course design, you have the big course, then you have sort of topics or modules, like you can think of a module roughly like a chapter if you have a textbook. So how many chapters or modules are there in a course, in your course typically? 5, 8, 6, something of that order, right? So you'll have chapter level or module level objectives, and then you will have what's called unit level objectives, which is for that day's class. Okay? So it's a hierarchy really. And the unit level or today's class level objectives have to address the topic level objectives, which have to address the course level objectives. So this is the structure. In terms of numbers, no, again, this is more like rules of thumb. It's not a very hard and fast principle, but I've seen course outcomes anywhere from 2 or 3 to like 6, 7, something like that. If you have 15 course level outcomes, that's too many because you won't be able to do justice. For a class, which is 45 minutes or 1 hour, again, there'll be 3, 4, 5, 7, something of that order. Because if you have 10 objectives for one day's class, you just can't do justice to it. So you may have only 3 objectives or outcomes for tomorrow's class, but there are maybe 30 such days that you will be teaching, and all of those together will address the course level outcomes, which is again something like 4 or 5. Yeah? Okay, that's an important question. See, the thing is, why do objectives in so much detail? When you start doing it, it seems like a bit of a pain. I mean, you've been teaching for 20 and 30 years, now somebody is coming and saying, make it precise, write action verbs and all. And the main thing is you'll get clarity on what exactly you want students to do. You'll avoid those messy scenarios, and it will help you align these 3 really well. The moment you're aligned, students' learning is higher, students' engagement is higher, you'll start seeing better results in assessments and things like that. Okay? So it's worth making the effort to at least start thinking in terms of objectives. Okay, so once you have these objectives clearly defined, written down, the next thing is to actually think of assessment. This may be surprising because I did not go from objectives to instructional activities. Normally, what do we do if we are planning tomorrow's class? We don't think of objectives at all. And we say, oh, tomorrow these are the topics, this is what I will do in class. We spend most of our time thinking about this, and only 2 weeks or 1 month before the exam, as your university is, or 1 day before the exam, you start thinking of assessment. Right? That's a standard way that most of us do. I also do that. But what this course design, this triangle of effective learning also encourages us is to start with objectives. That's why it's at the top. Then actually do assessment. So this is sometimes called backward design. This is what you want your students to be able to do. Now figure out how you will find out whether they can do it, and only then come to this. So we'll spend the rest of today and tomorrow we'll spend on this. We'll spend maximum time on this. But the order is this. Assessment is essentially a process of collecting evidence of what students have learned. It should reveal to us whether they have met the objectives that we have set for them, and so on and so forth. So let's spend a few minutes, about 15-20 minutes, on trying to think of assessment questions in a more systematic manner. Let's take these 4 objectives. And now I'm going to ask you a different question, some question that we haven't discussed. So are all these at the same level, and maybe level of complexity or easiness? You can think of what you mean by level. But are they all similar at the same level, or is there some hierarchy? What's the order in which it's written? Easy to hard, complex to less complex, how? Just get a feel for this, because in fact, it's enough to look at the action verbs. This starts with define. Define is usually one of the easiest things for anyone to do because it's a memorization activity. It goes to apply and then goes to analyze current and relate it to brightness. This is that exam question where students did so poorly and all of you said, oh, this is a hard question. So this is sort of in less complex to more complex. I want to avoid the word easy and hard. I'll just use the term complexity. And to assess students for tasks at different levels, we have a framework. We have several frameworks available to us. And some of it you may even be familiar. The main point is that assessment questions should correspondingly be at different levels. If your objectives are at different levels, assessment questions should be at different levels. The hierarchy of cognitive levels, there are people who have written taxonomies, which means they give us a set of different levels and explain what these levels are. Essentially, we write assessment questions for these levels. So ideally, I would have liked you to do this question with a neighbor in the same domain. Since we are very close to tea time, you'll do it with, if you don't have a neighbor, do it individually. If you have a partner, regardless of a partner or not, what I want you to do is choose a topic that you will teach soon. It can be the same topic for which you wrote the objectives a few minutes ago. But just think of a topic which can be taught, let's say, in 3 or 4 classes or 1 week. Roughly that larger topic. Okay, so let's start with this hierarchy of cognitive levels. Some of you may be familiar with the term revised Bloom's taxonomy or Bloom's taxonomy. So essentially this is similar to that, or this is the same thing that we are talking about. Bloom was an educational psychologist who gave this taxonomy, so it goes by his name. But what it defines for us is a hierarchy, and it defines for us that there is something at the bottom, things at the top which subsume the levels at the bottom. So we'll do 2 levels at a time. The lowest level, the least complex level, is called recall level, where students recognize and recall facts. They memorize and recall. Example, define current, state units of current, state Ohm's law. Many of you have thought about this. So we're moving from objectives to assessment now. What students have to do in such questions is retrieve relevant knowledge from long-term memory. So when we are doing this, just think of a similar question in your domain. So maybe I'll just ask in a few specific domains. Let's take people who are teaching computer science. Can you think of a recall level question in your domain? Compare various classification algorithms is a good question, no doubt, but it's more than recall level. Students have to do something a lot more complex. It's not, do you want them to only memorize it or actually take 2 things and compare its benefits and limitations? So compare questions are very good questions, strong questions, but they come at much higher levels. I'll come back to compare. So let's stick to this. Recall level question in computer science. Yeah. Define a process and its states. I'm assuming there is a definition of that thing. There is some known definition of process. Okay. So typically, the way to do it is you look at your action verbs. Define, list, state, identify. These are action verbs for recall. The second level is called understand. Unfortunately, this is a technical term, okay? A few minutes ago, I said, don't use the word understand. And now I'm saying, this is called understand. Understand means construct meaning, interpret. It's more than recall. It's less than solve a problem. So for example, here is a circuit, 2 bulbs are there. Maybe you can take this room, there are many bulbs here. What would happen if the voltage flickered? If the voltage suddenly increased? In many of our houses this happens. Suddenly, voltage starts flickering. So, the bulbs start flickering. So suppose the voltage increased. What would happen to the brightness? Would it go up or down? What would happen if the resistance went down? Okay, so they have to interpret. I don't want the answer to this question, but understand level questions are like this. Some simple qualitative reasoning. Somebody is, children are walking to school and one day, they don't walk at the uniform pace. For the first half, they walk at some pace. For the second half, they walk at a different pace. What would happen to time if this speed were changed? Would they be faster or slower? What would happen to, you're mixing, what would happen to the color if you mix some two things? So this is what we mean by understand level questions. They're simple. They're not yet at solve a problem. So this is a question, if 2 people are sitting in a bike instead of 1 person, what happens to the mileage? Will it go up or down? So a very standard understand level question. It's not very difficult either. Students have to know the relation between mileage and mass or weight. Maybe something about drag, I don't know, possibly. And they have to make some qualitative predictions. Okay, so this is a very fair, suitable understand level question. See, when you hear other people's questions, what you can take from it is the format. If something increases, what operating systems, okay. Okay, what would happen in a multiprocessing environment if something is increasing? Sorry, I don't know your domain. Again, it fits that format. See, you can even talk of, let me give you a few more examples. Anytime you ask students to explain with the help of an example. Yeah. So, give an example in support of this principle. Give an example that illustrates something. Those are all understand level questions. Because if you simply said state the law, it's a recall level question. But give an example which illustrates the functioning of this law is an understand level question. Okay, explain principle and working of some motor. That's also, so again, take away these formats. Explain the functioning of something, explain the working of something. The only thing is you have to be able to be clear as to how much you want students to be able to write. There was one more example, somebody, yes ma'am. Understanding about the gameplay, right? Yeah, that's valid. Okay, so let's move on to a couple of other levels. And the advantage we all have is that for each level, a lot of action verbs have been given to us by people who have thought through these things. So if you try to frame a question using these action verbs, you will be in good shape. Illustrate, I mentioned, explain, interpret, all of these are understand levels. Okay, the next level is called apply. Apply is a level that as engineers and scientists and college faculty, you'll all be very comfortable and happy with. Because apply level is most of your basic problem solving. Solve a problem, calculate current through the circuit. So now you'll start seeing that sometimes the levels which are close by get little tricky, whether it's in the higher one or the lower one. Don't worry about that. Solve, calculate, classify, predict, compute, prepare. Prepare a solution which has this level of concentration. A very similar thing to apply is the fourth level called analyze. Sometimes people get confused. Analyze is at a higher level than apply. By the way, any of the higher levels subsume lower levels. What I mean by that is, let's take apply, okay? Apply involves use of knowledge in a new situation with rules, methods, laws, or principles. So to apply a law, the student needs to grasp the meaning of the law, which means they have to be able to state the law. So to apply a law, the understanding and the recall level also need to be there. So the higher level take into consideration or subsume the lower levels. Analysis also involves a lot of problem solving. But the difference is that in analysis, exactly what problem to be solved has to be determined by the learner herself or himself. So if you take circuits, this one was a single circuit, calculate current. What law to be solved, which loop, all that is clear. Here, there are two loops. So, to break down a complex circuit into a smaller circuit is the process of analysis. Or if you have a machine, there are different working parts of the machine or of a device to figure out how those two parts are related to each other. Or if you have, I'm going to now come to the compare example that you gave, compare algorithms. You have two algorithms. And if you want a student to compare them, the student should know how actually they work. They should be able to calculate its efficiency and the process by which it works and so on. So in any of this holds, by the way, across topics, across levels. This holds in English, it holds in biology, it holds for 5th standard, it holds for college level and so on. If you're asking somebody to prove a theorem in mathematics, that's an analysis level question. If you're asking them to diagnose an error, that may be that may be analyzed or maybe even one higher level than that. Also, what should be the weight of the slab or something? Thickness of the slab. Okay, so actually it's your call. It's very hard for somebody outside the domain to say. What you have to see is this. Is it simply applying a law in a new situation? Or do they have to take this slab and tunnel and break it apart into small parts and then apply the law? Parts mean small pieces. If you say that I have to consider the weight of the slab, the tunnel, how big they are, how long it is, weight of the man, you have to see how many aspects of parts there are to the problem. If there are many parts which have to be first identified and separated, then it's analysis. So we'll just quickly look at the top two levels. The next level is called evaluate, which is essentially judgment making. Does something make sense? Is this correct? What is, here's an example, decide. Anything that starts with decide. Decide where something will happen. To make a decision, what all are required? Many things are required. Okay, you need some data, you need laws. You need to see how the data should be put into the principles. You need to, of course, know the principles. So, decision is a very complex cognitive task. That's why this is at a higher level. And the highest level is called create, which is mostly all the design activities. Write an essay is a create level activity. Design anything. Design a machine, design a motor, design a swimming pool. So, the takeaway here is the following. When you are setting assessment questions for your students, first write your objectives. And then if you really want students to be able to design a machine or write an essay, then you have to have questions at that level. If you want them to design a machine or write an essay, you cannot ask them questions related to solving a problem alone. You have to actually make them do design, both in class and in the assessment. Very good question. You're asking me to reflect. What is my objective for this session? Thanks a lot. So I did think about this. So there were a few objectives. Okay. First is I wanted all of you to be able to state what is a learning objective. That's a recall level objective. Then I want you to be able to differentiate between a valid and a not valid learning objective. So I'm not saying I want you to know. I want you to be able to differentiate or decide if a learning objective is valid or not. So can you recall what activities you did to achieve this objective, to decide if an objective is valid or not? What activities did you do? You framed objectives. Yeah, that was my third one. That is not about differentiating. This is the activity or assessment question which is aligned to the objective of learners should be able to decide whether an objective is valid or not. The third one is I wanted you to be able to write your own objectives where you actually framed your own objectives. So that's a subset. Thanks for the question.